The human brain is extremely sophisticated. However, there are some things that our minds simply cannot comprehend. The paradox is one such example. We've evolved to have a certain way of thinking about the world, but there are paradoxes that make us wonder if our assumptions about the world are wrong. And now some physicists believe they have resolved a conundrum that has been around for 50 years, but have they? And what more bizarre contradictions can you think of? Prepare to be surprised. When something is taken from the future and put in the past, the bootstrap paradox asks how it could have ever existed in the first place. It's a recurring topic that serves as the inspiration for many science fiction stories, including those in the Terminator, Doctor Who, and Bill and Ted movies. So let's examine one illustration of this dilemma. Imagine yourself as a time traveler, but before you embark on a fantastic trip, you visit a bookshop and purchase a copy of Shakespeare's play Hamlet. After that, you return to Elizabethan London and present Shakespeare with the book. After that, William S. steals the book and claims it as his own. A copy of Hamlet eventually turns up in the same bookstore where you originally purchased it after hundreds of years have passed. Therefore, the question is, who wrote Hamlet? Another well-known paradox has to do with going back in time to take out your grandfather, that is, to erase his existence. Everybody here love our grandparents, but this is only one instance. Once more, you travel across time and perform the act, erasing the memory of your grandfather. Returning to the present, you discover that your father was never born, your grandfather has passed away, and you were never even born. Your whole past, along with your family, friends, assets, and social network, have all been deleted. Therefore, it would be impossible to do this because you would not have been born in the first place. Theoretically, if this were to occur, you might have even created a parallel universe or entered one, according to some scientists. Going back in time to kill Hitler to end World War II is a fascinating variation on the grandfather paradox. There would be some intriguing effects of this. Let's imagine you own a sparkly time machine and have a plan to go back in time before the war escalates and make things right. The issue today is that the action eliminates all justification for time travel as well as any knowledge that such justification ever existed. Being a time-traveling executioner just leads to paradoxes. In addition to the concept of many worlds, going back in time might produce a new reality without der Führer, but the previous timeline would still be present. You might even make a new, more disastrous timeline. What would occur though if you attempted to send something back via a wormhole? The well-known theoretical physicist who authored the book on string theory is the late, brilliant Joseph Polchinski. But Polchinski has developed a scenario involving a pool ball that passes through a wormhole that goes back in time that would be paradoxical. The billiard ball is shot into the wormhole in this scenario at such an angle that, if it continues on its current path, it will exit the wormhole in the past at the proper angle to collide with its earlier self, throwing it off course and preventing it from entering the wormhole in the first place. Some physics students, however, have proposed solutions that avoid any inconsistencies by having the ball emerge from the future at a different angle than the one used to generate the paradox and deliver a glancing blow to its younger self rather than knocking it completely out of the wormhole. This blow changes the ball's trajectory in the proper way so that it will travel back in time with the angle needed to deliver its younger self this glancing blow. The black hole information paradox, a conundrum that arises from the marriage of quantum mechanics and general relativity, is one of the largest mysteries in physics. According to calculations, physical data may completely vanish into a black hole, causing physical states to deteriorate into one another. However, this is debatable because information cannot ever be destroyed according to quantum mechanics. Suppose you destroyed two distinct paper letters. It would be extremely difficult, but not totally impossible, to reconstruct them from ash. The two distinct letters would still be identifiable despite the minute variations in smoke, temperature, and ash content. Black holes have the drawback of sucking everything up and then, after a very, very long time, radiating what they have sucked back out as Hawking radiation. Unfortunately, Hawking radiation doesn't reveal what the black hole consumed, unlike the smoke, temperature, and ash from burning a letter. This is due to the fact that all Hawking radiation is identical, which suggests that black holes obliterate cosmic knowledge. So, does information actually be destroyed when a black hole evaporates, or does information somehow escape? According to a new generation of scientists, information does certainly escape a black hole through its radiation. They have also discovered an invisible area inside a black hole's event horizon known as the quantum extremal surface. This surface appears to encode the quantity of information that is radiated away from the black hole, changing over the black hole's lifetime precisely as anticipated if information escapes. Evidently, something is capable of leaving a black hole. It's a problem that hasn't been fully resolved yet and is still being worked on. Keep checking back here, and we'll let you know when we find out for sure. The Fermi paradox is certainly well known to many of you. This paradox, which bears Enrico Fermi's name in honor of the Italian physicist best known for developing the first nuclear reactor, aims to provide a solution to the query, where are the aliens? We should have been visited by extraterrestrial intelligence by now, it appears, given that our star and Earth are part of a relatively young planetary system in comparison to the rest of the universe, and given that a civilization could have developed interstellar travel during this time. Some argue that the dilemma isn't actually true because we can only assume that intelligent life exists elsewhere. The number of potential civilizations in our galaxy is, however, estimated using the Drake equation in this alleged paradox. To calculate the approximate number of observable civilizations in the Milky Way, the Drake equation uses 7 variables. This gave us the impression that there might be a huge number of Earth-like planets with advanced civilizations. But back in 1961, only our planet and a few others were known to orbit other stars. We only lately had a solid understanding. Using information from the Kepler Space Telescope, astronomers discovered in 2020 that the Milky Way contains more than 300 million worlds with environments similar to Earth. According to the data, about half of the Sun-like stars in the galaxy are home to rocky planets and habitable regions where liquid water may exist on the surface. In fact, there are more planets in our galaxy than there are stars. Additionally, the James Webb Space Telescope will launch into space very soon to search for additional potentially habitable planets. The question still stands knowing how many worlds there are and how many chances there are for advanced civilizations. Why is the cosmos quiet? We might soon find out thanks to technological advancements, or we might have already received a visit from a distant culture but aren't aware of it. Recently, there have been a lot of inexplicable UFO sightings, and some people think extraterrestrials are already present. That would end the dilemma if there was strong evidence for it.